Good evening, everybody, and welcome to the stream. I hope everyone's been having a fantastic and wonderful day and weekend, and that everything has been awesome and wonderful and fantastic. Because it should be. Because it should be. We're going to try and do some more programming today and hopefully get to the bottom of this mesh thing, because Last time I tried doing this, I was not in the right headspace. I was ill and I couldn't concentrate properly on things. So, but now I'm better, and I still won't be able to concentrate on things properly because that's it. But I don't have an excuse anymore. Yeah. So yeah. I just had to make some breakfast. I can't bother to wait till lunchtime. I mean, you shouldn't have lunch to breakfast anyway, so you shouldn't have breakfast at lunchtime. No, you should have, yeah, so, yeah, either way. But yeah, however, hello, Wanderer. I hope you have a good day. Let me jump over. I'm just going to go straight to this. Let's go here. Put myself down. Hello. We have a problem. There's a problem. There is a problem. Our test message with the advanced single stream. If I hit play, it throws a wobbly saying index 8 is out of range, which is here. And it's confusing because the vertices are still set to 24. The vertex counts are still set to 24. So I don't know what's going on there. I don't know why 8 is not within 24. But it's okay because I'm kind of going to scrap this one anyway because I have an idea. It's a great idea. It's a brilliant idea. The best idea in the times of ideas. So what is our problem? The problem is when we create a mesh. Let me enable this one here so you can just see. Okay. When we create a mesh, yeah, this is our yeah. We can resize it and it's fine, but we had problems with the texture coordinates being out on it and stuff not working. So in this quad here, the texture was fine. This one is reversed. And then these corner ones, it was all broken because they share things. Apparently, the way you do that is you use multiple vertex. So this one has 4 vertex for this one, and this one has its own vertex for 4 of them. It's still the same amount of polygons, same amount of triangles, but you add more vertex. So this one can have technically it's that way, can have a texture that fits on there perfectly, and then this one has a texture, this one, and so on and so forth all the way around. That's the way you do it, apparently. That's the way you're supposed to do it. However, we have a small problem with that. So what I want to do is when we enlarge this, we don't just scale the thing like this. We don't just make it bigger like that. We want to enlarge the center one, but have the outside ones be the same size. So these corner ones will always be a set size. But this side, and this side, north, south, east, west, will stretch to the size of the center box. Unless we want multiple rows of things. So this is where we need 2 different designs of things. So we have this one here, which works for the chips. The chips can all be formulated from this kind of design of chip, which is, no, you just stretch them out, that's fine, and the textures will be fine, and not a problem at all. The problem, and then all we do is we just add the pins underneath, not a problem. The problem is that when we come to a socket, we want to make a socket that actually has a square corner, but doesn't have an actual pin in the corner, so we'll do something else with that. We'll figure out how the sockets work. But the sockets might have multiple rows. Now, there are a few ways to deal with that. What I want to have the corner pieces never have a pin. A pin is never going to be in the corner of the socket. What I'm looking at here is the texture. So if I, well, we can't do it because the game doesn't currently work at the moment. Let's go to the test and just turn this one off and turn you off. Hit play. When we put down a socket like so, we zoom in. It's got this texture on the side which shows you where the pins go into. Now, if this was a standard socket that was supposed to be a square socket with like 120 pins in it, we need this pattern to be on the whole thing, the whole shebang. Because right now we snap pins in it and that's fine, but that's not the way I want to do things. So we also need this texture on the side. Now, right now, this texture is done by a shader which takes into account the size of the model and just spreads it along it. what I think I can do is I can actually take into account not just the size of the model, not the scale of the model, because we don't want to scale the model. We can do it on the actual physical size of the model. Like we can do it based on actual units. So if it's a 0.1 unit, it will repeat the texture this many times and it will do it all automatically for us. However, that is why we need here to make sure that this one scales correctly. But then if we're going to have another row of pins, we want to have another one of these inside. So the center one doesn't become as big, if that makes sense. So we're going to have the corners always want to be the same size. The corners can be a square. They don't have to be a this design. This is going to be for our chip, so they never have a corner. But the one's going to be a square. So let me let's load up good old paint in it. So what I'm trying to say here is if we have a so this is the size of our socket, and it wants to have multiple pins inside it. So it wants to have so it's going to have well, it won't have a pin in the corner, but it's going to have like like this. It's got pins on there, but it's also going to have pins on the inside row like this. Okay. What I need to do is when I create the geometry for this, then the corner piece is always going to be the corner piece. So these two corner pieces will always be the same geometry. That's fine. Then we have this one here, this, and there'll be one here as well, which is this one here. But then we need to create another one which has the geometry which is the same size as that one inside here for it, like this. But I can't do that because then this one would overlap it. I don't really want to do that. I don't want to overlap it. So we need to create a corner piece of each one, and basically we just need to add geometry out there. So we'll just do squares. So basically we'll do, the user has to give us a size. Let me go back to our chat. Where am I going here? Well, I've got everything loaded up in the wrong order. That's why things are going bananas for me. Not that one. Not that one. That one. We need chip dimensions. Okay, so the size of the chip. For socket, we need chip dimensions, amount of pins per side, amount of pin rows, and amount of pin rows. That's it. So that's what we're going to need for the socket. We need to know how big the chip is, how many pins it has per side, so how many pins it has here, and then how many rows of pins it has. And this corner piece here is going to have to be like textures is going to be one style texture. Then these ones are going to be another texture. So, but I have to create the geometry in a sort of way. It has to all just be made from multiple like things. So let's say, for instance, we have a chip that is it's 10 by 8 with 3 rows. Okay, how would we make a 10 by 8 with 3 rows? So we'd have to go, so it's going to be 10 by 8, so we'd have to go so this is the amount of pins, but we'd actually need the physical size of the chip as well. wouldn't we? I suppose we just do it based on this. We just do, like, when you create the chip, you say how many pins I want, and that is the size of the chip. It's based on the pins. It's not, you couldn't have a bigger chip with less pins in it. Yeah, I think so. 10 by 8. Okay, so if it's going to be 10 by 8, so it's going to be like that, and it will have, let's go with like 20. So it'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. That's not like that. And then to have 3 rows of them. So, obviously, we have the corner pieces. Oh dear, I changed the. I wish it wouldn't. I wish it would save the scale per tool. That'd be nice. There, but problem. So, this is one row. And it's going to have another one here. This. These will obviously all be to scale and not the way I'm building them here. And then boop, 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 like that. Okay. And that will have a socket in it, each one there, as will those ones. And then this will be, obviously it's supposed to be 8, so 1, 2, 3, 4, 5, 6, 7, 8. That's wrong because I can't put this, but you get what I mean. This is supposed to be 8, so it's 10 along, 8 there, and this will be 10. But that includes the corner ones. We just don't include the corner, so it's 10 internally. We just don't include the corner ones because we don't want to have the corner ones there. So yeah, which means if I was to get the fill tool and change to like a whatever colour here, so this one, this one, this one, and this one, and the center one are all one texture. The sides are going to be the same texture. Okay, and then all the other ones are going to be the texture that repeats the sockets, the little holes that look like a pin goes into them. But we need to build geometry in a very special way to know that. Now the size is easy. You just build quads and you just move them to whatever size you want to go to. So for this one, let's go with the blue now. So, oh no, undo that. Go back to this tool. Blue. Bring this down to like 5 or something. So obviously we're going to have this is where all our vertices are going to go, but it should still be the same amount of vertices. Actually no, it would be more vertices because of the way I'm building this down, wouldn't it? Don't worry about the sides, we'll figure the sides out later. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40 on that. But if it's going to be less than that, we'd actually use less geometry, so we'd have to figure out the amount of go. I don't know how to do that. We have to figure that out. You sent me a picture of your breakfast. I'm not going to get hungry. I am stuffed. I am stuffed. I have overeaten today. So I am very stuffed. That's if Discord actually wants to send me any pictures. Oh, very nice. Oh, lovely. Rolls with, I don't know what's inside them. Meat and something, some other description things. Nom, 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 nom. And then the side there would also be, because it'd have to be, the side panels. Oops. Just go down, yeah. Put it all with lettuce, tomato, ham, cheese, and egg. Oh, nice. Very, very nice. And these ones would also be that pink color. It'll be that. Boom, there. But that would be one texture and the other. So yeah. Geometry around here as well. Although these ones are shared because this is folded down. These are the sides. Okay. So yeah, they'd be folded down. I'm gonna have a quick nosy nose. Let's see if I play this. How far can we get in? We can't ever see the underneath of a chip. I might not bother rendering the geometry of the underneath of the chip, just to save such a headache on what I'm trying to build here. So it can be all the same. A chip doesn't need this geometry. A chip can be the standard one. The chip can be this this standard thing here that we're doing. It doesn't need the underneath of it. So, but I want to remake this because this is not ideal. So I have another one, which is the advanced multi-stream one. If I turn off this and we build the advanced multi-stream mesh into this guy, there you go, and we turn off the chip prefab, we don't want that anymore. We play, pause, we're going to get a quad that stands up on end, like so, for this, okay? So what I want to do then, go to this advanced single stream, not single stream, the advanced multi-stream one. I probably want to get rid of the single stream one, but I need that for the minute because I also need to grab the data out of this one because it's got our stuff in it. So, okay, the triangle index count is 6 because that's fine. Now, this is where I want to do things. So, in order to do multiple textures, you need 2 submeshes, or however textures you want. You need how many submeshes you have. So this will be one submesh, the pink, and the black will be another submesh. So when we create the thing, I actually want to create 2 submeshes. Work on the first one, and then work on the second one. Okay. Create the bounds for it as well. We can figure that out there. So, oh, this doesn't work because this is looking for something called. Wait a minute. How do you create multiple meshes here? So you get a, okay. You don't appear to be using things. So here's the normals. The normals all equals back. So the normals should all equals up or 1. We want to do that anyway. Get vertex data float 3. No, I need to do this in the same way the single one does it, don't I? Because I need to create the vertex. And then we set the vertex count and the triangle count. So I don't think the advanced one does it, because this right, hold on. Is you are, I know, because this creates one quad, doesn't it? Yeah. And then what we want to do is we want to basically just create multiple quads. But they want to be part of the same mesh. So this creates one quad here. Okay, so let's create one quad that's flat, shall we? So let's go 0, and then rather than going right, let's go position. This is going to be a float 3, isn't it? So let's go new float 3, which is 0, 0f, 0f, 0. Okay. And I was going around clockwise. He's not going around clockwise. Let's not do that. Let's not do the clockwise one. Let's do the zigzag one that he was doing here. Okay. So maybe very quickly. So this one was the right one. So this one wants to be start at the bottom. So we start here. So this is 1. 1, 2, 3, 4. That's how he's doing things. Okay, so that's 0 by 0. That wants to be on the x-axis 1 by 0, and then this wants to be up by 1, which is that, and then this wants to be 1 by 1. Okay. Now what I want to do is put in a better texture here, because I need to know whether it's facing the correct direction or not. So can we change the base match to be the arrow, please? Okay, there we go. And it's facing upwards, which is excellent. That's exactly what I want. Cool, cool, cool. It's too big. I know it's too big right now. That's fine. Doesn't matter. Boom. There we go. That's working fine. Okay. Cool. Right. So now what I want to do is I want to increase this, because we want to create let's create this one. Right now we'll just say it's a standard chip with no it's just got one row on it, so it'll be this one. So we want to create this one, this one, this one, this one. So that one, that one, that one, that one. So we want to create So we want to double this, and I want to double this. Okay. And then in here, we need to do a thing. So this to here. Okay. So this is where we create the quad. Create squad. The problem is, how would I... Public int to that was what you were just doing there, was fine. Yep, bottom. Then public int in equals 1. Okay, put on. How do I want to do this? If it's only a 1, we don't want to add any pins to it at all. Okay, it doesn't even want to be created technically. So this by minimum has to be a 3 by 1 works. So we'll do it a 3 by 1. Okay. So here, the vertex count wants to be, because we're going to create as many quads as this is. So we're going to create 3 across by 1, which, and 3 across by 1 is 3 pins by 1 pin, but I don't, if it's a 1 pin, we want to not have any pins spawn there. Okay, it must be a minimum of 3 pins for a pin to spawn. I think I might have a minimum size on the chip as well. The chip might have to be a minimum of like, oh, yeah. We'll figure that out later. Let's go with a 3 by 3. That's going to be the easiest way. 3 by 3. A 3 by 3 means we have 3 pins by 3 pins, which means it has to be 5 tiles wide. Pin rows. This is the bit that's gonna get me. So right now we're doing a 4 and a 4 and a 6, aren't we? Okay. So if the chip is going to be, so it's got the corner, 3 pins and a corner. There goes that. So that's what the chip will look like. If it's got 1 row, then the center is there. So we only need to do 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles plus the sides as well. So the chip. I'm sure I can set this to a fixed size, but okay, and then it's got a line across there. Okay, we'll have a 1, 2, 3, 1, 2, 3, like that. That's fine. But then if we add a how did I do this in this one here? How did we do this? We took the this one. So we grabbed the testing size. Okay. Because we need to shrink it down by 0.1. That's fine. That's okay. We did that there. But how do we? I think we manually set the vertex count because I was manually doing it, and then we're changing the size of it. That's not going to work for us. We need to build this procedurally. So I need to figure out how many quads I'm going to need for a 3 by 3. Yeah, 3 by 3 by 1 is this size. So that's going to be, we're going to need 1, 2, 3, 4, 5, and then the sides. We'll leave the sides for a moment. I'm just going to do a flat one for the minute. We'll leave it for a minute. So it's 5. But how do I get? Oh, actually, no. Okay, so the testing size doesn't actually change the amount. So by default, single row it has 5 top quads. Then for every row we add, okay, so for every row we add, we will end up adding 1, 2, 3, 4, 5, 6, 7, 8. For every additional row, we add 8 more things for it. So if this was a dual row one, it will have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pins, which is not right. What's 3 times 3? If it was 3 is 9, how would that make 20 pins? Oh no, it's not a 3 by 3, is it? It's how many pins are on the X and how many pins on the Y, and then how many rows there are. So it's how many are on the X, which is 3, plus how many are on the Y, which is 3, times 2, times how many rows there are. And that's not a Wahida. That's 24. And we only have 20. Oh, but you would, yeah. So there has to be something here for minimum sizes of things as well. Because if I went a 3x3x3 rows, we'd have one there, one there, one there, one there. Oh no, because there'd be one there, wouldn't there? But that doesn't work because that doesn't line up with the grid. We can't do that. So the rows must equals one less than the minimum pin size. Because if it's 3x3x3, then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, no, that won't work either because that's not on the grid side. That would have one in the center. Yeah, so it's got to be, if it's a 3x3, the minimum rows you can have is 2. The maximum rows you can have is 2. That's one less than the shortest size. Okay. Pin rows max one less than the shortest side. Okay. Pin total is equal to x times 2 plus y times 2 times rows minus 4. So So if we did a 5x5, that'd be 5 times 2 plus 5 times 2, which is another 10. So that's 20. Times, say, 3, we did 3 rows, is 60. Then minus 4. Would that be right? Would that be right? Let's find out in here, shall we? So let's so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Two, 3, 4, 5. 1, 2, 3, 4. 1, 2, 4, 2, 3. 2, 3, 1, 1, 1, 1, 1. That's it. That's as far as we go. Oh, that's yeah. So it's on a rough, you know. So we've got wow. We've got that one in the center there. There's that row. There's that row. Then there's that row, like that. And each corner will have to have its own individual thing as well. So yeah. What's that? So we got 5, 7, 14, 21, 28, 29, 30, 31, 32, 33, 34, 5, 6, 7, 8, 9, 41, 42, 43, 44, 45, and I've got 56. I need to take minus 4 times rows, don't you? Minus 4 times So that is 5 times 2, 10, plus 10, times the rows, which would be 5 by 5 by 3, which is 60. And we take away 4 times the rows. So the rows was 3, so that's 12. Take away 12, which makes 48. And then this was 48, was that right? 7, 14, 21, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. Right, okay, so my formula doesn't work, so this is 44 pins. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. 44 pins there, okay? So, and this is a 5 by 5 by 3. Okay, so what formula can we use to make that work? A 5 by 5 by 3. This one doesn't work.
Thanks for the raid, Huanaris, and welcome you 18 lovely people.
Oh, all right, thank you very, very much for the raid. I hope you are having a very, very good day, and everything has been awesome and wonderful. You playing Factorio? Awesome. Awesome, awesome, awesome. I hope you've been enjoying. Squirrel! Squirrels! Not the squirrels! Not the squirrels.
Thank you for the 33 long months of subscribing, Huanaris.
And 33 months as well. Thank you, thank you, thank you. Thank you very, very, very much. 2 minutes off work from now. Nice. Very, very nice. I don't know why I didn't read out the message there, but awesome, awesome. I've actually got, I'm in tomorrow, but then I've got the rest of the week off for Easter, which is quite nice. So yeah, awesome, awesome. Right, so this formula doesn't work. What do here? So, it can't be 5 times 5, this is 75, that doesn't work. So 10 plus 10 times 3 is 60, and then take away take away 12 doesn't work. I need to take away another 4 from that, make 44. So 4 times rows plus 1, would that work? Okie dokie, have a good sleep, enjoy, thank you very, very much for the raid again. I'm going to figure this one out eventually, somehow. Okay, so that works for that. So this is 5 by 5 by 3. So 5 times 2 is 10, plus another 10, times the rows, which is 3, and then take away the rows, which is 4 times 4, which is 16, which makes 44. Okay, so that works. But then what if it was a I don't know. Or like here. 10 times 8. I know this is all messed up here because I haven't got the right amount of numbers in here, but I don't know whether that's going to be, I don't know whether that formula works. If it was a 3 by 3 by 2, so that'd be 3 by 3 by 2, so that would be 6 plus 6 times 2, which makes 24, and then that would be 4, 8, 12. Take 12, which would leave 12 pins. One, two, three. 1, 2, 3. 3, so 5, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. No, because that would be 22. So 6 plus 6 times 2 rows is 24. And we couldn't even take 4 out of that. That formula doesn't work. Now there's another hedgehog on YouTube. Another hedgehog? There's many hedgehogs on YouTube. There's many hedgehogs on YouTube, I would expect. So there are 22 dots there. 5, 10, 14, 17, 18, 19, 20. 20 dots, yeah. But yeah, sorry, yeah, 20 dots there. But then our formula doesn't work for that either. The formula of, so if it was a 3 by 3 by 2, so 3 times 2 is 6, plus 6, so x plus y together, times rows, so there's 2, times 2 is 24, and then take away 4 times rows plus 1, but there's 2 rows, so that would be, take away 8, which would put us down to 16, and I'm going to put us down to 20. Right. So the formula is correct for this one, but incorrect for this one. If we just took away by rows, so the rows would be the 3 is 60. Yeah, so this one, so to get this formula right, you just take away the rows, which is, no, you do just take away 4, wouldn't you? Take away 4 from this. Right. I don't know if there is a formula for this to work, to be honest with you, because I'd like to do it procedurally, but I don't think I can. Also, generating this right, what if we did, hold on, so instead of being a 3 by 3, what if we plus 1 to it? So instead of it being, so it would be x plus 2 times y plus 2. That's not going to work, is it? So if it was a 3 by 3, that would be 5 times 5 makes 25. And then I need to take away 5 because of the there's 4 corner pieces and the center one doesn't have a pin. So take away 5 makes 20, which works for that. So this one would be 7 times 7. Take away 5 makes 44. That works. That works. And that should work for any scale, shouldn't it? Because we're doing the entire grid, so it pretends that there are that there is a pin there, 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 and there. Okay, which is a 7 by 7 grid. And you just take away 5 because there'll be those in the corner and one in the center gone. And it should work for odd numbers as well, shouldn't it? So let's say we add another. Oh, hold on. How big was I going? Was it 5? 5. Let's say we did that. Actually, let's go with one more. That won't work though, because there will be ones missing from the center. Like that, because the minimum grid row is the shortest one there. This would be 1, 2, 3, 4, 5, 6, 7. 7 times 5. Take away 5 makes 30. 1, 2, 3, 4, 5, 10, 15, 20. 21, 22, 23, 24, 25, 26, 27, 28. Because there's 2 more in the center that should be missing. That would have to be, in order to calculate that, it would have to be x3 times y plus 2 minus 4 and then minus x minus y. So we've got 5, 10, 15, 20, 3, 4, 5, 6, 7, 8. So there's 28 here. Okay, so this is 28 now, right? And this is a 5 by 3 by 2. Not the 2 matters at all. The pin rows don't matter. So we go 7 times 5, which is 35, minus 4, and then minus 5 take 3, which is 2. That doesn't work. No, minus, because it'd be the modified, it'd be minus 7. 7 minus 5 is still 2. Oh, take 5, take 2, isn't it? So minus 5, and then minus x minus y. This is a weird formula, but it works. It works. Put it here, and then I need to just get my brackets right. So x plus 2 times y plus 2 minus 5 and then minus x minus y, but these must be into a positive that x minus y must be a positive number. How do you make it a positive number? There's a thing to make it a positive number. There's a math function to make it a positive number. That'd be the pin total, which is fine, but that's not what we need for making our this here, because this is not going to have that many. That's how many pins there is, so that's fine for the pin total. But the quad total is going to be quad total is going to be we're not including the corners because the corners don't count as quads. So we've got the corner pieces like this, but they aren't actually going to count because they are yeah, the corners don't count. Corners aren't going to be there. So I need 1, 2, 3, 4. You have to build it this sort of way, depending on how many. So there's going to be 4 for the outside, whatever. So the actual ones that are going to be for our so we're not going to do those ones. Are the blank ones. These are the texture ones, and we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20 of them. I think it's going to be easier if I just actually don't do this sort of thing. If I actually build this in just quads, each one is a quad. That's going to be the easiest way to build the whole thing, isn't it? So the pin count is going to be the quad count, but we have to do something special for the corners, but we don't want to do that there. So that's going to be the thing. So the pin count pin count equals pin count, but corners are a special case because they're not quads. Gary, hello, good evening. I hope you're having a good day. Yeah, because the corners are not quads. Rise, not quads. Okay. Okay, so the vertex count is equal to the quad count times 4. I could probably share some of them. I don't really want to. Times 4. So hang on. So mesh, right, sub mesh. This is coding. Sub mesh 0 vertex count is quad count. No, so the sub mesh 0 is going to be the vertex count's always going to be the same for sub mesh 0. Sub mesh 0 is the one that doesn't have the repeating texture on it. So it has like that. Okay. And it doesn't have anything here, so this is not a quad. Okay. Let's get rid of this one down here now. We don't need that, as I said. Yeah. Way too technical. It's mathematics. It's mathematics. Yeah. It's simple. So yeah. So let's go have it there. So and you're going to. So you will have 4, 3, 6, 9, 12, 16. So 16 vertex for the top, and then the sides have so they're going to have that the sides of the, not the chip, but the sides of the socket are going to want to be their own submesh as well. But then, yeah, because they're going to have another texture on them. So I'm going to need 3 submeshes here. We're going to have 3 submeshes in total. The top with the blank parts, the top with the pin holes, and then the sides with the plugs in them. But if this, we've got a special case for some. We'll deal with the special case now. Right, so yeah, so this is gonna have to be filled in another different color just to there. So that's gonna be like a because that's submesh 3 and submesh. Oh no, actually, because yeah, no, that's right. It's right. Sorry, I'm talking to myself. Something like that. Don't worry again. Because there's going to be 1. Wow. There. These are some really bad because I haven't made everything the right size. So, like that. But okay, they are part of the submesh for the non one there because they won't. The corner pieces won't have anything. So there's going to be they could share because they don't have a texture, so they could share stuff. So that wouldn't. So 16 for the top, and then 4, 8, 12, 16. And then 16 B for the side. Like that. Okay. Okay, so 16 for the top, 16 for the sides. That's fine. And then that is 0. Submesh 1 is going to be this one here, and this is submesh 2. So submesh 1 is going to have 4 times the pin count. Okay, so 4 times pin. Okay, boom, that's easy. That's done there. Boom. And then submesh 2 is going to have 4, 8, 12, 16. 16 sides. There you go. Okay. Because we'll have a 4 here, because they will have a repeating texture on them as well. Although I don't know if these should be made up of individual quads or no, because the textures are based on as a material. Right. And our materials can be repeated based on our shader graph. Tile texture thing can be done. Yeah, so we can do, so the material's made from the texture and then we can repeat it depending on how we go. Okay. So Submesh foot count equals no, not quarter count. The submesh 0. Let's put this in brackets here. Non-textured corners and center. Vertex count is equals 16. 16 plus 16. 16 top plus 16 side. Okay. Sub mesh mesh 1, which is the textured pinholes. Vertex count is the pin count. And then submesh 2, which is the actually vertex count is going to equals 16. I have no idea how to allocate multiple. I'm going to assume that the submesh. I'm going to make an assumption here, which may be a bad thing. If I had 3 of these here, it's going to pick the submesh for each one. So I'm going to go with grey, gold, and silver, just so we can see the different colours of them. Okay. So as it creates them, we will do the thing there. So we'll hit play. The rest of the scene. You have gone with gold because that's the final. Actually, it's the second texture. Why have you gone with the second texture? That's weird. Why have you gone with the second texture? How strange. Okay. Okay. So, submesh 0 price is going to equals. I don't have a damn clue. Well, this one will be set, won't it? Because it'll be 2, 4, 6, 8, 10, 11, 12, 13, 14. Okay, which is 14, but that's not how it works. The triangle index count is 14 times 3. Okay, 14 times 3. Which is equals to 42. Hold on, there you go. Okay, the submesh 1 tries count is equal to the pin count. No, it's not. It's going to be equal to the vertex count times no, because they share. They share, don't they? So the triangle count here in the center is 6 because it's 1, 2, 3, 1, 2, 3. So that makes it 6. That's 4 plus 2. That's 6, 12, 18, 24, 30, 33, 36, 39, 42. That's still right? That's still right, yeah. How did I figure that one out? How did I figure it's 14 times 3? How did I wait, what did I just say? What did I just say for that? How did I figure out this is 14 times 3? Because I counted the amount of triangles there'd be, didn't I? So it's not vertex count. Well, it kind of is. It's vertex count divided by 4 times 3 is going to be the same thing for all of them. So it's yeah, vertex count divided by 4. Because it's 4 per one. So vertex count divided by 4 means that's 1 quad. So we've got 1, 2, 3, 4, 5. 9. No, hang on. That doesn't make any sense. It's not vertex count divided by 4. It's vertex count divided by 2 times 3. Okay, and then submesh mesh 2 triangles is literally just going to be 2, 4, 6, 8. So that's going to be 6, 12, 18, 24. It's going to equal 24 because it's hard coded, because the sides are stretched. So even though this is 1, 2, 3, 4, 5 quads along here, the side piece will only be 1 quad. I need to know all these numbers because I need to figure out this here. The vertex count is fine, I can stay there. But I need to know the vertex count and the triangle index count for each of the submeshes. And I'm going to have to program each submesh individually as well. Okay, so we're going to want to allocate 3 submeshes to this thing. Okay. If I press play now, mesh array data length must be 1 to apply to one mesh. Was 3. Okay, I don't want to apply it to one mesh, I want to apply it to 3. Where was that error? 98. Here. Apply dispose mesh data array. Oh, do I have to do like a 0 here? Nope. Oh, okay. Okay, so how, right, mesh data array length must be 1 to apply to one mesh. Don't apply to one mesh, don't apply to 3 meshes. What else is in here? Ah, we have to do meshes. We have to create multiple meshes, don't we? We get the mesh data and we do all the bits that are there. Where do we create a mesh? Where do we just create this mesh? Mesh is mesh here. Right, so I need to meshes equals new mesh 3, please. for meshes.length. Boop. Mesh filter. To maybe 8-bit. I'm already confusing myself here. Right. How do I apply the mesh filter? Let's save that. I don't think this is going to work because we're not applying the mesh filter, are we? Yeah, we're not going to see the thing, are we? No. Well, I need to apply the mesh data. Okay, what if I apply mesh data 1 to it? See, this is the bit that I'm a little confused on. I don't get how it does multiple meshes. Render has more meshes than the mesh has sub-meshes. How do I find out? Filter dot shared mesh. Equals, I can't just assign meshes to it because it's how do I do that? How do I do that? So submesh count is going to equals 3. Okay, there we go. So it worked, and we have the grey for the first one. If I change these around, it changes to gold, changes to silver. Excellent. Okay, cool. It works. Right. So that's the trick. I need to add these sub-meshes to it. Right, okay. I'm kind of learning as I'm going here. You might have figured it out, but it's a bit of trial and error. But ow! Oh, itchy ears! Oh, I need to get a headset that doesn't make my ears explode. Oh, but I'm trying to. Oh, there we go. What I'm trying to do here is I'm trying to figure this all out kind of on my own, if that makes sense. I've got the stuff in front of me that I understand how all this works, and I could probably just Google the solution and try and figure it out, but I want to learn how it works so that then if you the way at least I work is that if I go through all this and I figure it all out and then get it working, I remember how I got it working, rather than just copy paste from somebody else and be like, oh yeah, there it is, it works. Just because something works doesn't necessarily mean you understand how it works. So yeah. Okay, and we just add mesh 0 to the component filter, I think, maybe, hopefully, I don't know. Let's try and change this now. Let's grab mesh 1 instead. So yeah. Oh, so I get a headset for my ears. A big thing on top of my ears, right? Right. So if we get mesh data 1 instead, and we assign mesh data 0, let's find out what happens in that case. Okay. Do we see the thing? We don't see it. The renderer has more materials than the mesh has submeshes. Okay. Why is that? Why is that? So what I need to do is I need a function down here, which is going to be void create quad vector c vector 3 that's not going to work. Hold on, I can't create a quad from that. First position. Okay. So let's move all of this here into here. So you don't have a clue with the mesh data and stuff, do you? Yeah. You're going to need to have mesh data. Is it mesh data? No, it's mesh data. It's about that one, mesh data. What am I wrong? Triangle index tab. You don't know what that is. We set the vertex count there, and then we set the that can be done outside of here. It can be done here. Okay, so we do with all the mesh data stuff there. Okay. And then we just go create quad, mesh data, we'll start at 0. Okay, and then what I'll do is I want to go with this is float 3. Wait, positions is float 3. So this wants to be a float 3. Okay. So this wants to be first position, and then this one wants to be first position, actually undo this, do that. Okay, so you offset by 1, 2, 3, 4. I'm not sure why some of you are green and some of you are yellow. That's very bizarre. There you go, you're all green. Okay, and then you do this, and this is fine. However, this is not going to work because we need to know what vertex we're on as well, don't we? the text cores, all this needs to be offset. The normals needs to be, every one of these numbers, these 0, 1, 2, 3, need to be offset by so I need to send in a vertex amount. And a triangle index amount as well. Because the triangle index needs to be increased by 6 every time. And the quad needs to be increased by 4, which is enough done. The problem is that's why I did this here, and these will do offsets based on the original positions. That will still work though. Be playing. Still works. It creates it. That's fine. Okay. So what I want to do is I want to now I want to copy because I need to change the index count and all the bits and pieces, don't I? So what I need to do is I need to basically duplicate all this, which is very annoying. It's interesting, it sets all this stuff. You don't need that. This can all be set up before the mesh data has been created, can't it? So we set the vertex count and the triangle index count. We then get mesh data 0 and then apply that. Then change the vertex and triangle count and redo this and create mesh 1. Right, okay, let's get method and call this oh no, cancel that. No, cancel, undo. You are not doing it the way I want you to do it. Not that. Come down here. Void. It wants to be a mesh. Yep. Oh no, not that. Bump. This was mesh data. Damn it. Mesh data, mesh data. We need to know the vertex count, and we need the vertex attribute count. Well, the vertex attribute count is always going to be 4. Okay, so we're never going to change that. That's always going to be 4. We know that's the case. Okay, also get rid of all these. Like that. There you go. That makes so much more sense. And then get rid of. Put them all on one line to make life easier for me. So the vertex count needs to be sent in as well. So int vertex count. There you go. Okay. This doesn't need to exist anymore because we know this is always going to be 4. Just comment that out for the minute. Okay. So here we get the mesh data, and then we go rename this to create vertex attributes. Up here we go create vertex attributes, mesh data with vertex count. Okay, save. So we'll then move these around a little bit here. Hold on, no, we don't want to create one mesh, don't we? We want to add to different submeshes. So how do I set submesh 0, the triangle index count? Right, so the mesh has got an, okay. So we need to create all the vertex in one mesh. Hold on here. Move that one. There you go. Mesh and then mesh. So I was doing it wrong. I don't create multiple meshes. I want to create meshes, but I want to create the sub count, the sub mesh count to 3. So when we set the sub mesh, so we create one mesh, which is fine, and we create all this here. So this could actually have gone back up there again because that doesn't need to be. Yeah, let's take that back out again and put that up here because we're not going to create multiple of these, are we? So, paste that back in there. Get rid of that one. That doesn't need it to be there. Okay, it's the triangle count, isn't it? This is the one where the submeshes happen. So we create a submesh and we go submesh 0 is a new submesh descriptor, which is the index start and the index count, and this is all the triangles. Okay, so we have to create the whole thing, and then we just need to know where our triangle counts for submesh 1, which is going to be the blue ones. And then where it starts for 2, which is going to be the interior ones, and where it starts for 3, which is the outside ones. So we need to build this in a very different way. Don't need that. Oof. Let's go. Speak up. Where am I going? Here. Yeah. So I was messing up my things there. So that's fine. For the vertex count and the triangle count, we have to calculate not from each submesh. We need to add them all together. So we need to know the size of our thing as we go. That's 4 times a pin plus 32 plus 16. Equals 4 times pin plus 16, 32, 48. I'm going to chop the corners off them, aren't I? So it's not 4 times pin. So the vertex count is going to be, actually, it's going to be x plus 2 times y plus 2. So that's our complete grid around the top, minus 4. Because of the 4 corners. That's 4. And then we need to add on 4, 8, 12, 16, 32. Oh. Okay, because of the top and side. No, not all right. So that covers it there. So yeah, we have to add on 32 because there's going to be here, 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 and here. Then these ones here. So there's going to be a quad here. So the yellow ones be 1, 2, 3, 4 quads there, and the corner ones 1, 2, 3, 4 quads there. Okay. So it's going to be x plus 2 times y plus 2 minus 4 plus 32. So let's try this here. So let's plug this formula into it and just see whether it likes that or not. You don't know what x is, do you? It's x, yes, right. X size and z size, not y size, z. It should be z. Idiot. Okay, right, what's wrong with this? Pluck but float to int. Because it should be head size x, piston size y. Now, does that work? Does that need to be? I don't know the order of operations for mathematics, because the way I was taught it in school was that you start at this end and work your way through, and then later on it's like no, you have to do plus, then times, and then minus, then divide, and it reorders the whole thing, which just doesn't make any logical sense in mathematics. It just doesn't. It's such a stupid way of them doing things. No, always do multiplies first. No, just start on the left and work to the right. It's just what? Why? Why would you do such a thing? Yeah. So. Debug.log. Let's hit scan. Yes, do that. Okay. Do that. I don't know how many that's supposed to be. How many would that be? So what is our actual thing set to in Unity? Hold on. Heads massive. What's that? The thing that annoyed me is that I don't remember at all in school being taught order of operations when sums come along. I don't remember that at all. It was something I learned after I left school, and I was like, oh yeah, that's always how it's been. You know, you always do multiplication first, then you do division, then you do the plus and minus. It's like the addition and subtraction. And I'm like, that just doesn't make any sense, because it just doesn't physically make sense to get a sum that has like this here, and you do this part first, ignoring that this has test inside plus 2. So you ignore that and you do the multiplication first. It's like, that just doesn't, the logic doesn't make sense as to why they've chosen to go that route with it. It's just stupid. Whoever thought that up, it just, no. Just start this end. And then, so you take this number, then you add to it, then you times it, then you add to it, then you, and that's it. Unless you have parentheses, that's what they're for. But no, apparently you're supposed to take the sum apart, do the multiplication first, and it just breaks the sum. It just absolutely breaks the sum. You know, so it's just, it doesn't, it's just weird. It's just so strange to me that they decided upon that. It's not a natural way of looking at it. It's just so weird. So I need to make sure that this actually is doing the thing I want it to do. I need to make sure I put this in parentheses and this in parentheses, so it does does testing y plus 2, and then times these two together. Okay, because otherwise it will do the multiplication first. It will do that bit first. Which just, why would that's not, no, so weird. Anyway, so we are going to go with a let's go with a 5x5 by 3. Was that what we've got in our picture? Yeah, 5x5 by 3. Okay. Right, so 5x5 by 3. The vertex count should be what we've got written down kind of here. So 4 times the pin size. So 5x5. So 7 times 7 is 49. There's 49 pins there. Okay, well, there's 49 squares for the pins to go in. Minus 4. Because we're taking away the corner ones, because we want to smooth the corners out. So take away the corner ones, makes 45. Then we add 32, which makes 77. According to my calculations. Let's see whether Unity agrees with me. It says 45. See what I mean by order of operations? If you go to a calculator, you type things in order. So I'm typing these all in order. But no, that's not what comes out of it, because that's not how you do. You do something different here to than you. It just is so stupid. It's so stupid. What if I did 32 there? What if we did that? Okay, so we'll go to calculator again. So 32. Oh, and then actually I need to put these in parentheses here. Okay, so we do that too. Let's try that. Let's try that. It's, as I said, this is something that's caught me out so many times when doing maths, because it's just it's not intuitive. It's just not intuitive. I don't know what idiot thought. So there you go. Now we've got 77. We're at 77 because I moved this number 32 to the start instead of putting it at the end. because stupidity. I don't know. Maybe it would still work on the end anyway. If I hold on, plus 32. Whoa, no. Plus 32. Thank you. Okay. There we go. Boom. Okay. If I put this all in parentheses, so I want to do this sum first, and then do this to it at the end. So maybe that'll give me the same result. Hold on, let's see. 77. There we go. So it was doing, if I don't put this in here, it was doing something here first and then timesing it, which is not the order of operations that I've typed it in. So it's hey, who am I to argue with 100 years of mathematics that just don't calculators don't do that. Calculators don't do that. If I type it into a calculator, it goes this number, then this number, then this number, then this number, then this number. So why is it different when it comes to actual calculus? It doesn't make sense. So broken. Anyway, so the vertex count is 77. Okay, so the triangles should be the triangles would be divided by 3 times 2. 77 divided by 3 times, whoa, 77 divided by 3 times 2 makes 51 point, no, that's not right. Divided by 2 times 3. 77 divided by 2 times 3 makes 115.5, so that doesn't work. Because we're going to want it's 7 times 7, because that's 5 times 5 is 7 times 7. Okay, so that's the top. 7 times 7, that's how many quads there are. And that would be doubled because the triangles are doubled. So times 2 makes 98. We then take away 4 triangles because of the corners. We take away the 4 triangles. So take 4, put on 94, and then we're going to add 1, 2, 3, 4, 5, 6, 7, 8. Add 8. Okay, so we need to get to 102 from 77. So if there are 77, because if you have a single quad, it's 4 vertex. You divide it by 2 and then you times it by 3 and you get 6. So if I was doing the corner ones here, it would be, so it's not 77, is it? Could we taken the 4 away? So it's hold on, what's the number here? So minus 4 plus 32. So it's 7 times 7 plus 32 makes 81. That's still an odd number of vertices. Why are we getting an odd number of vertices? And that's not even right, actually, because that's the amount of pins, isn't it? I need to times that by 4. 7 times 7 times 4 so yeah, so it's not 77 vertices, that would be 77 quads. So 77 quads times 4, but it's not 77 quads because of Yeah, so it's 7 times 7 for the top piece. That's how many. So there are 49 pins in there, and then we take away 5 to get to the pin count we want. So we have to times that by 4 because there's 4 vertices per quad. Okay. We then take away 4 from that because the corner pieces, and then we add 4, 8, 12, 4, 5, 6, 7, 8. 8 times 4, 32. Then we add 32 to it. So add 32 to it means we should get 224 vertices for this thing here. Okay, 224. Right. Let's see whether this works here. Hold on. Oh, it's got redundant things in there. It says so. Let's see whether that sum comes to 224. It doesn't come to anything because I got rid of the debug statement. Debug. Boom. Boom. Thank you. Bum, 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 bum. 224. Yay, it works. Okay, cool. Right. So it says that these parentheses that I've got here are not needed. Okay, so let's get rid of them, and then we'll run it again just to make sure the numbers add up to the numbers I actually want them to physically add up to. 224. Cool. That's right. 224. Awesome. So do that one too. That number's wrong. So it's 2, 2, 4 vertices, and triangles is that number divided by 2 times 3 should be 336. Now the problem is I don't actually know whether that number is correct or not. I'm just assuming because of how we're building this thing. So I'm just going to go with that. So it will be vertex count times 0.5. Oh no, I need to go divided by 2, don't I? Times 3. And I think I need to put this one into parentheses just to make sure it's doing stuff in the correct order. Nope, it says I don't need to. Okay, so it's going to divide first and then times afterwards, right? Triangle in its count, so do that. Okay, so we should get hopefully 224 and 336. Play. 224 and 336. Excellent. Awesome. Index buffer element 6. 65535 is out of bounds. The mesh is only 224 vertices. That's fine. We haven't actually... Wait a minute, why did that throw a wobbly though? Why would that have thrown a wobbly? Index buffer element number 6. Value of 65535. That's the maximum number you can count to on a uint. That doesn't make any sense. Okay. This is where I need to be changing stuff based on the mesh count. So like if I just set that to 6, it goes from 0 to 6 for some mesh 0. Still throws a wobbly though. That's weird. Visual mesh 69 now throws a wobbly. Really? Why is that? That doesn't make any sense. Oh, we might be having limits by the by this. I don't know what a uint goes to. I need to do uint 16. 65535. Unassigned integer. That's fine. So it goes to 65535. Our triangle index count is. It's only 336. Oh no, I think I know why. It's because we're only filling 6 of them. So it doesn't know where the others are. So I need to set this to 6. Yeah. I need to remember I've done this one and this one. Yeah. 6 equals triangle index count. Remind myself I've done that. Yeah, I think it's because it's setting the index count. The vertex count can be blank. You can have blank vertex, but you can't have blank triangles, I think. Yes, there we go. Go to the scene. There it is. Hey, cool. And it's not moaning about that because it knows it has 3 submeshes, even though the other submeshes have no data inside them. That's fine. That's fine. So we create one mesh and then we assign the submeshes by splitting them up depending on their triangle index count. Okay? So we want to build the whole thing and then split it up as we go. So how about we create quad and then we move this over by 1. Now, you're going to create the positions here of 0, 1, 2, 3. So this isn't going to work. So we need to have an offset, don't we? So int vert index int try index. Okay. And this should be vert index plus. Nope. Vert index plus. So you're going to start recommending to me. Yes, you are. Excellent. Thank you. Right. The normals, I think, also are vert index, aren't they? Yep. The tangents are also on the vertices. That's the same thing. Oh, undo. I just push tab to move to the next one as well. No, here, this one, please. Thank you. Okay, you are the vert index. Are you the vert index? Stream. No, you're upstream, so that's fine. You're text coordinates, so you are the vert index. Okay, but you are going to be the try index. Okay. Not recommending it to me. Oh, really? How disappointing. So this is going to need to have 0, 0, and this one's going to have 4,6. Okay, just manually set them for the moment. Right, that should create a double one for us now. Press play. 6 is out of range, is it? Or 6 out of range? Because that needs to be updated to 12. Okay. And then I want to copy this one, paste it down here. We want to set submesh 1 to start at 4 and go to 12. Okay. So this is creating all the codes we need, so we can do this. This will be fine, won't be a problem. And then we just tell it where the submeshes are made or submeshes are indexed. Nope, we got it wobbly. Oh, count. Oops, sorry. Sorry, the count. Ah, okay. Right, so that's so start at 4 and then count 4 by 6. Sorry, I didn't realise that. Hey, there we go. Right, put on. Ooh, now that's interesting. It's overlapping, and I don't know why. Scratch my ear. Why is it overlapping? You should have. You should have gone. That's strange. You are working, so we've got 1 gold, 1. So you should have gone. Go up on the Z button. Oh, oops. No. What's going on with my icon? Go away. This is wrong. This needs to be vertex, doesn't it? Vertex. Do I have to cast this as a U short? Cast this as a U short. Do not cover into U short. What? But I want to. Okay, I'll tell you what we'll do. We will change this U short to be a int 16. Not if you look at it short. Why could I not convert the int to a short? I know they do shorts. I know why they're doing this, because it's all to do with programming and making stuff quick. It's all to do with making the thing as small as possible in memory. That doesn't waste memory. That's a uint 16, which is fine. Can I not change this to a uint 16? Why can I not? What the? Oh, I have to. Oh, okay. Right. This should be 1, 1, 2. So you have to put them all in brackets, which is yeah, okay, yeah, because it's not using the vert offset, is it? So that would be why it was binding the triangles to the wrong thing. So okay, all seen, right. The only problem is I don't see the other triangle. It should be on the Z-axis there. Why do I not see the other triangle? Why is that? That's weird. Why is the submesh set to the vertex count? Or it actually be set to 4. We don't want the whole each submesh having the same vertex count. Each one should have its own individual vertex count, right? Oh, hello. All right, it's got something going on here, but it's very broken. Okay. So that means I've done something wrong here somewhere. So the first one works, but the second one didn't. Why is that? You should start at 4, start at 6 for the triangles. Okay, so your vertex index should be 4, that's fine. Can I see the vertices of a thing I'm selecting? Was there a thing for that? I'm sure there was. Gizmos, I don't want that. Don't want layers. Don't see it anywhere else. It's got 212 vertices, 4 triangles, 3 submissions. That's got two triangles, 6 indices, 2 triangles, 6 indices, but it's not showing the second. Excuse me, the second submesh. Okay, why is it not showing the second submesh? If I change you back to be the vertex count and see what that does to it. I don't really want to add that many vertices to each individual one. That's not really going to be what we're after here. 124 vertices. Okay, so it doesn't care about that. Right, okay. 6 indices starting from 4. 0 indices starting from 12. Yeah. Why can't I see the next one over? Okay, so that works. So it is definitely there. I can't see the second submesh. How about, oh, undo. You go 0. Come on. You go from 0 to 6, which means you should draw in exactly the same place. Play. Which you do. Okay, right. So why can you not go from 4? Because you're looking for the triangles. And you want to go from 6, 4 by 6. Idiot. Not 4 to 6, that's not going to work. 4 to 6 doesn't make any sense. There's too many triangles in the wrong place. There we go. Ah! Because I'm counting triangles, not vertices. Awesome. Awesome. We have managed to create a mesh with 2 submeshes on it. Nice. One that, one gold. So it just automatically applies these in order to the submeshes. That's brilliant. That's really good. That's really, really good. Okay. Scratch my ear. Oh. Right. Right. Okay. That's cool. That's fine. I have no idea how I'm going to get these numbers to stop being magic numbers and go be the thing. But that's okay. So I also want to change all of these to be 0.01, don't I? This wants to be 0.1. This wants to be 0 point, and this wants to be 0 point. Sorry, 0 point. Point 0 point. Thank you. And then 0 point. There we go. They're all. Actually, I can all stay at 0. That's fine. Just to make them all match up there. That's fine. So they're all going to go off into a 0 point. So I don't really need this here, but that's fine. So then this one wants to go 0 point here. Okay, save that. Play. And hey, we have a teeny tiny one. Awesome. Awesome. Right. Right, okay. Okay, so we know this is correct. This is fine here. This is fine. This is all working absolutely perfectly well. I don't need to worry about the X and Y sizes. That's not all that important. We'll leave them in there for the minute though. So I want to create I need to manually create the corner pieces and know where they are. Which is not really a major problem. And then create the side pieces. Well, I need to create all the blue pieces first and know where they are. The center one size depends on the amount of pins and the rows. That's going to be a complicated thing to do. How do we go around doing that? Because what we need to do is take the X and the Y, or the X and the Z, whatever, you know, the X and the Y, and blah, blah, blah. So it basically it needs to expand to the size of also we're just making a socket here. I'm not making a chip because a chip has a different layout to it, so we'll have to figure that one out. Although the overall size of the thing will be the same, so when we create a if it's a chip, it will have to have a flat top and a different bottom. So yeah, so if it's a 5x5x3, it'll be this, so that'll be the smallest size it can be. But if it's a 5x5x2, then this row won't be here, and then we need to enlarge that. And if it's 5x1, it needs to be even enlarged as well. So how do I create I might just flip these round and actually have and do the pin holes first. Yeah, do the pinhole first, and the CPU will be done differently because the CPU won't have all these in it. It will have the CPU chips will be done different to sockets. We're working on sockets now, so I want to create a complete grid of all the things. So here we're creating the quads. I want to create to do a for loop here, don't I? For X and Y. Yeah. For int X equals 0. Yep, do that, but we don't really want to do this. That's not what I want to do here. So don't want to do that. So, I mean, that's correct for the position. That's fine. We want that. Yep. The vert index is not going to be that. The vert index wants to basically increase by 4 every time, and the triangle increases by 2 every time. Let's come up here and let's go int vert index equals 0, triangle equals 0. Oop. Vert index plus equals 4, triangle plus equals 6. It's smart, it knows. It knows. Okay, let's get rid of that one. Okay. Okay. I'm gonna have to have another thing stored up here somewhere. So it's going to be a private int 2 submesh 0 triangles start and count. Think. So it starts at 0 and counts to so we can go submesh 0 start and count dot x a equals the try index okay, and then down here is exactly the same thing except it's y. Okay. And then I want to, whoa, yep, and yep, that's what we want, yep, and then once we've done this one, we can then do the next ones, and that'll be absolutely fine. Save all this, see where this works. So we start it here, we iterate through everything, and then we finish here, which means we know how far we've gone. So we start at 0, and we count however far we've gone. The next one will start at however far we've gone on the previous one, and so on. Hopefully. Wait. No, we went wacko. 12 is out of range. Why is 12 out of range? That's because here the triangle count. Ah, damn it. I want it to be the triangle index count, but I can't do that. Because if you don't fill up all the triangle indexes, it doesn't work. Yeah. Buffer element 296. It only has 224 vertices. Yes, I know, because we're not filling the other vertices up, are we? Of the other triangles up. Damn it. Can I set the mesh buffer data later? Can I put that down here after the bounds and stuff, so I can change that to be that's a temporary fix. Change to probably let's go. Will that work? I don't know. Index 0 is out of range. Yeah. We're not assessing the index. I need to know the amount of triangles before I start adding the triangles. Ah. That is annoying. What is test inside X and Y set to? It's set to 5 by 5. Okay. What's that going to be? 5 times 5. Actually, going to be 7 times 7, isn't it? Yeah. That's no. This needs to go up. S inside .x plus 2. It does go plus 2. It knows it goes plus 2. Oh, okay. So it's 7 times 7. That's 4. Divided by 2 times 3. It'll be 294. But let's set this to 294 if my calculations are correct. They were correct. Interesting. Oh, it did it. It did it. Obviously, it's not. Interesting. It thinks that's the center of it, though, which is weird. Center, yeah. For some reason it thinks that wow. Okay, it thinks the center is yeah, because the bounce. Yeah. 0 F 1 F. Okay. No. Can I not do the bounds? Okay. And set the bounds and just get you to recalculate it. Be fast about the recalculation of the bounds. Oh, there it is. Right, okay, and then double click. Oh, double click, zoom in. Okay, so now it thinks the pivot point, the center and the pivot point is there, and it's got no bounds. I bet you it's got no bounds at all. That's fine. We'll figure that out later. However, it has made the grid, which is beautiful. But now what I want to do is I want to make sure that I want to skip over the corners. So I just need to check if X is 0 and Y is 0. X is 0 and Z is 0, sorry. So if X is 0 and Z is 0, if X equals 0 and Z equals test dot Y, continue. Yep, and then yep, gone. Okay, so if it's any of those, then skip the corners. I'm also going to turn off this one for the moment. Oh, no, I need to leave that one in there for the minute because it's doing things. Emble, hello, good evening. I hope you're having a good day. Oh, yeah, damn it. This 294 is no longer 294. It now comes down by 2468. So it becomes 286. Kind of annoying that you have to know how many triangles you have before you start making them, because like, well, I don't know how many I have because I don't know what I'm doing yet with it, so. Where are you throwing that wobbly though? Find the array. Okay, can we debug.log try index. Can you tell me how many triangles you think we've got? 270. Why have we come down from... 2, 4, I should have just got rid of 8 of them. 2, 4, 6, 8. You reckon it's 270 now? What? Oh no. Yeah, no, I get that. I get that. I need to do +1. Sorry. I need to do +1. Yeah. Here we can all the switch tools all sorted out. That's not surprising. If somewhat stupid. What has happened here? Right, I need to get rid of that other quad. Let's get rid of this one. Let's see whether you break everything. Nope, you don't. Okay. What? Oh yeah, the submission. Can we on it out? A submission for the minute, thank you. Right. Is that one wrong? Why is that one wrong? Because I didn't put the +1 in there. Problem is that I'm only getting rid of one vertex here. And if I'm only getting rid of one vertex, that means that there's another vertex there, there, and there that aren't used. And I'd like to be able to identify those to fit in the corners. I'm not quite sure why it's doing that. It's just camera distance, okay. You just don't bother with the corner vertices, you don't draw stuff. But I know there are vertices being made in those other corners, so you're making the one there. For that, oh no, you're not. No, you're making, yeah, no, that's fine. But now what I want to do is I want to go to the rows here, the pin rows, and I want to go how can I do this? Oh God. So So if I can't out right, so it's starting from the middle corner and building across. Okay, or actually it's going up, I think, going that way. But either way, so this is a 3. If we had this as a 2, it means we don't want the center ones filled in. But how do I know whether I'm on that row? 0, 1, 2. If X is 2, so that's 0, that's 1. X is 2, but that would be there. So if X is 2 and Y is 2, then don't. So if I need to not fill in the center ones, don't I? How do I do that? To go if X is I don't want it to happen if X is equal to the number of rows. So if we have one row, if X equals 0, so if X is less than pin rows, no. If X is less than pin rows, let's just go if X is greater than pin rows, continue. Okay. It's going to break my triangles again. Ah. How can I find out how many triangles I'm going to have? I need to work on. I need to figure this number out. This magic number here needs to be a formula of some description. Because the triangle index count is only true if the vertex count is 100%. The vertex count may not be 100% because yeah, it may not work that way. Why can't I have empty triangles? Why can't you have empty triangles? Could I just set all the triangles to 0? Which would waste a lot of resources. Can I? Then I come down here for I equals strength. So this I equals 0. Okay, and then we just change this to be triangle index count. And we're filling all of them in with 0. And then we overwrite them again later. That is a complete waste of resources. Absolute waste of resources. Okay. Oop. Okay. Because if I now go to this procedural mesh, it's going to tell me it's got 52 triangles. Actually, that works. If you set all the triangles to 0, it must ignore them. It must ignore them. Yeah. Yeah, it must do. Because it would have more than 52 triangles. Right, okay. So that works. We just fill it with empty data. So long as it's got some data, it works. Okay, that fixes the problem of trying to figure it out beforehand. I just fill it with empty data and move on. Right. So, this is the one now. This is the one that we're going to have fun with. I'm not sure why you've done X. So you're doing the Y, you're doing the Z first, aren't you? You go over the Z one first. Then you finish the Z, you go X. So you go up. Fine. Let's do the same here. If Z is greater than pin rows, then continue. Okay. That should build a much smaller cat. So we got our pin rows are currently set to 3. Let's set them to 1. Hit play, see what happens. We get that one shouldn't be there. This is 0. Oh yeah, because it'd be -1, wouldn't it? The pin rows -1. Pin rows. Okay. So that should just build 2. No, it's not built anything. Why is that? I need to figure out so if X does not equals pin rows -1, continue. Okay, so I built that, and then it won't go any further. Okay. -1. Or x does not equals testing size dot x minus pin row. Okay. So what if we did and z does not equals pin rows -1. Skip this version. Play. Cool. Okay, so now I just need to get the top ones there. I want to change this to if x does indeed equals pin rows -1 and that equals pin rows -1. Okay. Then we want to do this. Okay. Or x equals testing size dot x minus pin row. And z equals testing size dot y minus p. Now this isn't going to work. If x is less than or equal to, and z is less than or equal to, or this is less than or equal to and less than or equal to. I don't know if that's going to be correct. It doesn't feel right. Yeah, building all the bottom ones. Don't want to do that. This one be greater than. Okay. Nope. Try this one first. Nothing. Why is that? If you're less than or equal to pinrose -1, pinrose -1 is now 0. So x should be 0 and z should be 0. That should work. That should exist. Look at these to run around. Okay. Is it not -1? Is it just pinrose? So if I set the pinrose to 2 now, interesting. We get, oh yeah, because of the corners. Right, okay. Then I want to copy this and paste it again. Except we want to go and do this side of it. So this wants to be play. No, it's not what I wanted. Okay, so this one is doing the inside line. I need one that does, if it's greater than the testing x minus pinrose. Well, there should be an or as well. That might help. Like that. Hey. But index 224 is out of range when we're 224. Because I'm increasing the verts too many times. Right. So I'm trying to get it so that it sort of like that, but I want to go more than that. So I think I need to do a very complicated sum there. So it's 10x plus 1 minus pin rows minus 1. These might have to be like that, because I need the sums to be done in the order that I expect them to be done in. Hey, there we go. Awesome. Okay, so if we go down to one row now and hit play. Hey, awesome. Let's see whether this works if I do a 7x3. Okay, play. It does. It does. 7x3 with 2 rows. It does. Now I need a failsafe in here to make sure so if pin rows is less than testing test inside dot x minus 1, or pin rows minus 1 rows must be less than the size of the chip. Yep. Well, okay, throw wobbly. Pin rows must be less than the size of the chips. I mean, it is. Oh, no, sorry, not less than, greater than. Yeah. What is side of? Okay, so it's all working absolutely fine like that. Okay, and if I go and put 3 down here and hit play, it'll throw an error going, no, you can't do that. You're not allowed to do that. Okay. So if I did a also the testing sizes always need to be odd numbers, don't they? That's something else I can fix later. So let's do a do they have to be odd numbers? 10 by 10 and make the pin rows 5. Play scene. Yeah, I think. Well, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Actually, no, maybe not. Oh, yes, they do, because it's offset. Yeah, so these always need to be an odd number. Although you are off by half, aren't you? So you need to do 0.05 by 0.05 snaps into the thing, and I can't click it because it has no bounds. So let's go down here to where we marked about all the bounds and stuff. And bounds equals new bounds, which is going to be a new vector 3, which is going to be X size, Z size. It's going to be 0 by 0 by 0, And then X size by 0 by Z size, which is the only place I think I'm using that. Play. Oh. Oh.
Oh, I hate that hedgehog.
If it sensor, so you still see the sensors down there. So I can select it there. Why would you hate me? Why would you do that? Ah, so I need to make it double the size. Is that right? How'd the bounds work? So the center is there, and then the size. Oh no, this needs to be X size. X size by Z size. Needs to be X size by Z size inside. Well, but there are no squirrels here. There are no squirrels here. No squirrels here. Oh, hello, what was here? Oh. Okay. I can physically see the hitbox of the thing. Because I can't select it here, but I can select it there. Also, this is going to be broken. A 9x9 with 5 pin rows. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The pin rows must be half the size of the testing size. I just realised. Must be half. Half the size of the shortest side of the chip. Also, I don't know why I did +2 to these. Yeah, I don't know why I added +2 to these. That's not what I want. You make the chip size and then you do the pin rows, and it tells you how many pins you get. So the chip if the chip size is going to be 9x9, you'll get 7 pins in it. Well, maybe the pin size would be easier. So, I did not see what you said on YouTube. Oh, and there's also one there. Oliver, hello, good evening. You spoke. Oh wow! So I guess my YouTube integration has broken. When did that die? I am so sorry about that. It was like an hour ago. Sorry about that. I don't know. Why did you disconnect from YouTube? Why did you do that? That's not reliable. Yeah. Okay. What the whole mesh thing is for? The whole mesh thing is so that in the game, when you create a when you research the process. So right now we have a set chip. Oh, sorry. So that must be 4 minimum. Okay, so we have this, which is set size. Okay, it's a 40-pin set size thing. Okay, I want the user to be able to create chips of whatever size they want to create. So they can create a chip that is 40 by 3, whatever, you know, it has 40 pins, so they can recreate this chip. That'll be fine. But the idea would be that if you want to add technologies into your chip, so if you want to add, there's going to be obviously different technologies you add to it, so AVX and SSE and all them sort of things. The chip has to become a certain size. The die has to become a bigger size for it, and also the more connection points you have for things to happen down the chip. But I need to dynamically create that so that the user can go, the player can go, well, I want to research a new chip, and I want that chip to be 5 by 5, for instance. So I can have five pins on this side and 5 on the other side, and 5, so I can have 20 connections to it maximum on the outside, until you get multi-layered stuff, which becomes even more complicated. But rather than having to manually create the 3D model for every possible configuration, because there might be some mad person out there who decides they want a chip that's 100 pins long and only 2 pins wide, then yeah, I would just want it to have it so that it can be, these can all be created in game. They can all just be made by the game. So hence why I'm doing this, trying to create the thing here. So I know this looks like arrows at the moment, but if you can imagine a CPU, well, actually, so where was the so that's not a very good. Show me a picture of a land grid array. No, a pin grid array. PGA. So yeah, that one. So there. That's a CPU socket with all the pins in it, and here would be the CPU socket, and each one of these squares is a pin that goes in there. They are all kind of offset slightly, but we're not going to do that. We're going to do it in there. So you can create this socket with however many pins you want inside the socket. That's the idea. That's the idea of it. So it can be made by the you can generate it whatever size you want to do it. So if you want to go and make a chip that is 5 by 27 long or whatever, you can go and make that chip. There you go. There's the socket, boom, and then you can put your chip inside that. So, yeah, which isn't that far off the actual one we've currently got, really. I mean, it's a bit far off, but you know, it's similar to the one we currently have, if that makes sense. You know, so that socket is 5 by 22. So 5 by, was it 22? Yeah, I think it was 22 with one play. If I move this into the world here, we go over to here just to have a quick look at it. It's all messed up because it's all mixed in with the thing, but and then we go and do our. So yeah, it's close, but yeah, but you can create this socket in the game. The user can create this socket in the game. So yeah. It's actually bigger. 1, 2, 3, 4, 5. Oh yeah, we're still adding. That'd be 5 pins by 22. Means that's technically bigger than the size we have here. So that would actually be a 3 by 20. There it is. And that socket is the same as the socket we currently have. There you go. So it's the same, exactly the same size as what we currently have. But if the user then wants to go, well, hey, actually, I want to have it to be 5 wide instead of 3 wide, then that's the whole idea of it. It can be generated by the data you put into it when you research the thing. So but I am getting there with this. This does make sense. This does make sense. So yeah. Also want to make sure these are always odd numbers. They should always be odd numbers, but yeah. Okay. So that's been done. We don't need to change that. That's been done there. That's fine. Trying this is working fine. This is doing the job here. It's not fitting in the center of it, but if we put more pin rows in there, it will fit in the center. So this creates our submesh in the center, which is fine. Now what we need to do is create the centerpiece. So I don't need that and that anymore. That'd be fine. Oh. Oh. I need to create the centerpiece. So centerpiece sized based on now. Jokers, hello. Apparently my YouTube integration has broken. I do not know why, but apparently it has. So I don't know how to get it to reconnect. How can I get you to reconnect? Oh, apparently my there you go. So my token to sign into my YouTube account must have expired during the stream, but there was no pop-up to tell me it expired because I had to re-sign in and accept it. There we go. Okay. Okay.
Hello there.
Hello there. I am, however, going to be stopping in a moment. It is 20 past 2 in the morning. I am tired. And I'm disappeared. You can't see me anymore. I'm not even here. But I've gone from, I've had 2 streams or so with this mesh thing where I've been banging my head up against the wall, And I now actually feel like I'm achieving stuff with it. Like it makes more sense to my head now. I must have not been well. I must have not been well, and I just couldn't see what I was trying to do. Great. Submesh 1. Create centerpieces based on the chip size and the pin rows. Create corner pieces and side corner pieces. And then submesh 2. Create side pieces. Based on chip size. Based on chip size, no. Chip based on chip size. That's it. That's all we need for that. So cool. Okay. Need to create quads. I do need one that also creates triangles. I need to create another one that creates triangles. So just for those ones there, that shouldn't be difficult to do though, at all. So okay. Cool. Oh, you know what I didn't do here? Don't recalculate bounds. So for some bizarre reason, the bounds doesn't work. But let's actually tell it don't recalculate the bounds, because it might be that it was recalculating them incorrectly based on the wrong information. So let's go to our play. Go here, scene. Over to this guy here. Nope, you are definitely not in the center of the option, the thing. But down here I can't click it, but then here I can. So it ends up being clickable here, but not here to here. Okay, so the center times 0.5f would be there, and then it comes out that big. That should work. That should work. I don't see why that won't work. It's closer, but it's not right. It's still not right. And yeah, I don't think that there, so it's not quite extending out far enough. And I bet I know why it's not extending out far enough, because I'm adding 2 to the testing size when I'm building it. So I don't want to do this. I don't want to be adding 2 to it, do I? Yeah. Let's try not adding 2 to it. Is there anywhere else I do that? Yeah. So if we did let's do a 5x5 again with 1 pin row, press play. That will now not create the outside one, which is interesting. -1 testing. So I'll do it. So testing.x is 5 and Pinrose is 1. So you go to. Do you want to go +1?
Squirrel!
Squirrel. No. This is all. It's all correct. It's all focused. It's all the thing. It's all right. It's fine. It's fine. Play. Oh. Mesh has indices. Oh yeah, because I can't go +1 here because we've had that over there. So does this need to be +2? Yeah. That doesn't feel right to me. Nope. Still doesn't feel right to me. Ooh, so if we go +2, this goes +1, minus that -1. The Pinrose. Oh, greater than. Should just be Pinrose -1, shouldn't it? But we're gonna go up to testing. Right, play. No, it still hasn't worked. No, why has it not worked? Why? Why? Not permanent bit. No. No, I'm a high quality streamer. Not no. If it's greater than or equal to testing.x minus Pinrose -1. So Pinrose is currently 1. So 1 minus 1 is 0. So if it's greater than testing.x or equal to testing.x, then it should be fine. Do I need to put this as an equals? No, because that's going to throw wobbly on the vertex, isn't it? Yeah. Maybe we don't do -1 on it, so we always take away 1 from it. Minus Pinrose. I mean, that's right, but I don't know why you've done the corner ones. Why have you chosen to do the corner ones on that one? Oh, these should not be +1. That's why. That's why. Oh. Right, okay. Play. Boom. Nope, that still isn't going the way I expected it to. These have to be -1. Because we don't, if it's less than this, we only go up to it. We don't go, we start at 0 and go to it. You don't start at 1 and go to it. There we go, there we go. The 5x5 chip has a 3x3 set of pins, okay? So now if I go and do a 11x5 chip with 2 rows, there we go, okay. And it looks as if I can click on the entire thing correctly. The center is correct. It does need to be oh, hold on, it seems to have snapped. A minute. Ah, yes, because the object's a different size now. But that does make sense. Okay, cool. There we go. Awesome. Right, so let's still remove the corners. If we went and made an 11x11, there it is. And it also snaps to the correct things. And if I click off it and on it, oh, it doesn't quite. Oh, it might be clipping through. Can't keep me 8-bit forever. I'm not allowed to. Nope, it is working. Awesome. Okay. All I need to do is I need to, for this chip, for instance, we need to make a quad in the center that is this size, or this socket, I should say, which is this size. We have to make the corner pieces, and then we have to make the pieces on the side to make it a 3-dimensional object, because if it's going to be a processor, it needs to be a 3-dimensional object, which is fine. I have realized as well that when we're creating the quads, I need to create quad with position. The position needs to be 0,1F because we create the quad above. There we go. So that would be where the socket would be, and then we'd have the edges come down and they would fit into that beautifully well. Awesome, 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 awesome. And then the only other thing we need to do is actually find out whether I can stay 8-bit forever, or right, remove this component, is to find out whether I can actually convert this to a entity. I hadn't really thought about that. We need to add a baker to it and then do that. The problem is that the baker stuff all needs to be inside the entity subscene, doesn't it? That's okay, because I can drop this in the entity subscene anyway. Oh dear. I'm gonna stop. I'm gonna stop in a minute because I hope I can bake this into the entity manager. I hope I can create this object and then send it into the game manager, or the build objects, and send it to here. I really hope I can do that. I need an anti 8-bit. That's what it is. I need an anti 8-bit so you can take it out of 8-bit. Yeah. I need 408,000 on Twitch. Is that all? I don't know how many I've got on Twitch because it doesn't tell me. It doesn't tell me I've got on Twitch. YouTube will tell me. Nah, just over 500,000. Yeah. Yeah. Right. Okay. So I'm doing all this here, and I really hope, I really hope there is a way for me to take this procedural mesh and then bake it into this, because I hadn't thought about doing that. So yeah, I can turn you into 8-bit. I can make chat 8-bit and give it really bad font. And they're weird, but anyway, we're gonna leave this one here. Yes, we are. Yes, we are. Mainly because if I do this, I don't look so 8-bit. So
Yep, I yawned you, Eggman.
yes. Yes, it's 23 in the morning, so the sleep is required. But I do genuinely feel like I've actually progressed sometime this time round. This time round, I've finally done that. But I really hope I could, even if I can't bake the thing.
Where's the kaboom? There was supposed to be an earth-shattering kaboom.
Even if I can't procedurally generate it with a mono behavior and bake it that way, I do know there is a way you can generate meshes in entities. So we can still do it. We can still do it. It still can be done. Just requires another bit of converting, but that's okay. That's okay. It's a learning experience. Learn to digging. I'm trying to talk here. Do you mind? Do you mind? I'm trying to explain what's going on, because you know, I don't have a clue half the time. So it's nice to be able to explain to people that something's happening, because yeah. But anyway, we're going to leave this here, and we are going to come back next time and carry on from there. Tomorrow we're going to do some more Mobius, the Mobius strip. So yeah, it's the blind leading the blind. Yes, absolutely. The blind, deaf, and yeah, just yeah, it's but it's good. It's learning. We are learning. I'm learning. I don't know if any of you are learning, but I'm learning. I'm figuring stuff out, and yeah. And I've only had to look up one thing today, which was how far a uint goes, which was as far as I thought it did. So yeah, but I can now procedurally generate meshes at runtime. And it's not done via the magic numbers. It's done via a loop. It's done via a loop. So yeah. Anyway, I'm rambling here. I am absolutely rambling. So yes, we shall leave this here. We shall come back next time. I think it's on cooldown. And we will yeah, we will, yeah. So tomorrow is going to be the Mobius machine again. We're going to carry on with that, and then we're back to stuff on Tuesday, and we'll take the week as it goes. So yeah, there might be some odd streams this week as well because I'm off work, so I don't know whether I will be streaming some extra stuff or not, or whether I'm just going to be playing Marvel Rivals all week. I have absolutely no idea whatsoever. So thank you for watching, everybody. I hope you have enjoyed this one. I do hope to see you again in the next one, and until then, as always, stream the Rivals. Maybe you should come play the Rivals with us. That's what you should do. Yeah. But until next time, as always, have fun,